Thank you for joining us. Today we're going to talk about advanced automation with ePolicy, Orchestrator, and tagging. This is part of the McAfee EPO Best Practices series. We should be familiar with the typical EPO architecture. You have your EPO server in the middle. You've got agents talking to that EPO server on a regular basis, sending up events, collecting policies from the EPO server, deploying any content or updates via distributed repositories on the left-hand side. In addition, you can have an agent handler over in your DMZ for clients to talk to EPO remotely. They could be at a Starbucks or at some different location where they are not on the local network. And then in the upper right, we have automatic responses, a very powerful feature of EPO that allows us to take action automatically and automate some of the things that we do on a regular basis in EPO that may be normally a very manual process. And that's what we're going to talk about today. So first, let's talk about tags. Tags is a function of EPO 5.1, the latest version of EPO, and it goes back several versions to as far back as EPO 4.5. A tag is nothing more than a label that's assigned to a system inside of EPO. And that label can be anything you like. It can be something simple, like it's a workstation or a server or a machine running Microsoft Exchange or SQL. A tag is nothing more than a label or a sticker that you assign to a system. Many of these can be assigned in an automated fashion using EPO properties, such as a server or workstation or operating system or IP address. That's the automated tagging. And then there's manual tagging, which we'll be focused on today. And that's nothing more than creating a label or a sticker inside of the tagging system in EPO and saying maybe this tag is a machine that's under a threat or possibly infected or unhealthy for one reason or another that you define. The beauty of tagging is a system can live anywhere in your tree. So it's not like other consoles where you have to move a machine to a different location. You can, maybe a group called infected. You don't have to move that machine. Wherever it resides, maybe it's in an office in New Jersey or in EMEA or any location where it lives in the tree, you don't have to move it. So that sticker is applied independently regardless of where the machine lives. Now, once you understand those basic concepts of tags, well, you take it to the next level. Client tasks inside of EPO are nothing more than something that runs on the client in a scheduled fashion. So that could be your virus scan on-demand scan that runs at 3 p.m. on Fridays. It's something you schedule, or something that you can, of course, schedule to run immediately as well. So what we do is leverage automatic responses, which again is that automated system found in EPO, that assigns a tag to a machine, and based on that tag, we launch a client task. And it's nothing more than the 3 steps that you see here. Create a simple tag, and we'll kind of run through that. Create an automatic response, and then finally assign a client task to that tag. So let's go ahead and look at that workflow inside of EPO. So like I said, step 1 is going to be creating a tag. And here you see my EPO server. And as you can see, I went to my tag catalog, and this is it right here. These are all the different tags I have. Of course, your EPO environment might be different. So as you can see, we'll focus on these 2 right here, under threat and virus found. And let's actually open one of these up. Let's do virus found. And we'll go ahead and say edit. And everything in EPO is always a simple 4-step wizard. That's the beauty of EPO. It's very simple to use. So I created a tag called virus found, and as you can see, the goal here is to launch an on-demand memory scan when a file is infected on any machine, and we want to do that immediately. So I'm going to go through the wizard. Step 2, it'll say, okay, well, do you want to assign this tag automatically through one of these criteria on the left that the EPO agent collects? So the answer is no, but of course this is a great feature as well. A very popular one is laptop. So you can say assign a tag of laptop to machines where the EPO agent recognizes the chassis and it says it's a laptop. But again, we're not going to do that. We're going to leave this blank. Go on to the next step. It's nothing more than a radio button that says only run when a run tag criteria action is taken. So again, we're not automatically assigning these tags through the tag catalog. And finally, go to the very last step and hit save. And it shows us that 0 systems will be getting that tag, which is accurate. We don't want anyone to get it right now. Now, we move on to automatic responses. Automation, automatic responses. Let's see what we have there for that specific automation thing that we're going to be doing. So that's this one right here. Virus found, launch an ODS. So I'm going to edit that. I kind of pre-created it beforehand. As you can see, I give it a nice name. I enable it. It's an EPO notification event. It is a threat in terms of event type. I run through the wizard again. So it says, okay, well, when do you want this automatic response to occur or to trigger? And in my case, I chose if the machine lives in my organization. This is my tree structure. I could have just as easily chose a different location such as New Jersey, New York, UK, whichever group you want to settle on. But I chose my organization right there, which is everyone in my tree, obviously. And I said if the detecting product is virus scan 8.8 and if the event description is infected file found. So this helps me realize that I have a machine that had some kind of virus on there. Obviously McAfee detected it to an extent, but maybe the virus was already in memory. And at that point, if the on-access scanner finds that this machine's infected, it's going to attempt to remove the files that are residing on disk, but it will not clean the infection that's in memory. That's where an on-demand memory scan is extremely powerful. We recommend running an on-demand memory scan frequently, at least once per day, because A, it uses minimal overhead on the machine because it's only scanning memory, and B, it is the only way to remove a virus that's residing in memory. An on-access scan will not do it. Go on to the next step. I want to trigger this response for every single time this occurs. So if a machine gets, a virus now, or if it gets one 3 hours from now, every single time I want this automatic response to go off. And then finally, the most powerful area of automatic responses, I'm going to run a system command and apply a tag. Now, if you remember, I created, 2 tags earlier. Actually, this is the right one, virus found. If this event occurs, and a file is infected, found on a machine, we want to apply this tag to that machine, virus found. And subsequently, we could wake it up. Otherwise, we may be waiting a couple minutes before it calls into EPO, before it gets this tag. So we want to wake it up sooner than later, and I'm going to wake it up immediately. So the second we find a machine that sends us an event, a file infected, we will trigger this automatic response, apply this tag, and wake it up and have it call into EPO to get its associated client task. And finally, I save it. Now that I have this automatic response, what do I do from a client task perspective? Let's head over there. Let's go to my system tree. I'm at the My Organization level. I choose Assign Client Tasks. And again, these are scheduled events that occur on my systems or clients. And here is the one that I'm concerned about, on-demand memory scan. I go ahead and drill into that. And this is the actual scan that VirusScan is going to do. Here are the 2 key points. We want to scan memory for rootkits and running processes. Again, this task will be very light in terms of utilization. It does not touch the actual hard drive, very fast, usually 1 minute in length. End user does not notice anything going on their machine because it's so darn fast. And it removes any machines that are infected in memory. There's certainly other fields, but these are not that important because we're doing everything in memory. We're not scanning the actual local disk. Clean and delete. Most of the other defaults are fine. Again, the most important value is just making sure you have these 2 right there. I go ahead and save that and I call it my on-demand memory scan, and then I'm going to take a look at my schedule. And really, the most important area, which is tags. So as you can see, we choose the product virus scan, on-demand scan. There's my on-demand memory scan, which can be utilized in other places in my tree. But here is the most important part. Send this task to only computers which have the following criteria right there. And the answer is virus found. That's where tagging comes into play. So I could have used this tag, I could have used multiple tags, but again, based on my automatic response, we are going to use the virus found tag. So only machines that have that tag will get that task. And as you can see here, I have set it to run immediately. So the second it calls into EPO after that wake-up call, it will run that task and launch that on-demand scan. So that is obviously one way to leverage automation, but you need to realize the power of this automation. There's so many other things you can do in an automated fashion. And the one that we focused on today was essentially finding a machine that gets some kind of infected file event. That's great. Maybe it removed the file from the local disk, which is great. I mean, that's awesome. But if that machine was already infected in memory, let's say 3 hours ago before a signature was found, then it will stay infected in memory even though we removed the file from the local disk. That's why an on-demand memory scan is valuable. Now, of course, you could schedule an on-demand memory scan to run 2 times a day. But wouldn't it be great if we automated and were laser focused, so the second we get that event, we target that on-demand memory scan immediately without wasting any time. The end result is, as you can see on the bottom, you're going to have less infections that are long-term. So maybe by the time you run your on-demand scan, maybe it won't be for a day or two, and that person stays infected for several days. Why would you want to do that unnecessarily when we can go ahead and focus on those machines that get infected immediately? This also reduces your risk of outbreaks. So the longer a machine stays infected, or the more likely that code can change and maybe spread across other machines in your environment. You want to target it, clean it, remove what's in memory immediately. Less help desk phone calls. That end user might not notice that there's a piece of malware on there immediately, but 4 hours from now, when his machine is running slower or getting pop-ups, then they're going to call the help desk and have a negative impact on your cost of operation. So, of course, the sooner we clean it, the less likely they're going to call up the help desk and possibly get their machine re-imaged or open up a ticket and essentially waste your valuable resources. And, of course, significant reduction in manual remediation. No more re-imaging or less re-imaging for that matter, depending on what kind of actions your organization takes. So that's also very valuable. Now, in addition, another great, I'll give you one more great automation scenario, is using GetSusp. So as you can see here, there's a tool we have called GetSusp, which is short for Get Suspicious, and I have the link for it right there. That tool allows us to run silently on the client, and maybe this time a machine got infected, but it did not get detected by McAfee. Maybe it's a brand new infection, maybe it's a targeted attack towards your organization. McAfee does not have a signature for that piece of malware as of yet. GetSusp is an automated tool that can be deployed via EPO to automatically attempt to capture all suspicious files. We'll do a quick scan. We capture anything that's suspicious in memory, send it up to McAfee Labs for analysis, again, automatically without you lifting a finger, and possibly get a new signature written for it if it is a legitimate new threat that McAfee is not detecting as of yet. And essentially, you're going to take all those things that we just learned in terms of automation and do it with GetSusp. So let's take a look. So as you can see here, back to my tags, I created another tag called Under Threat. And this will be a machine that in one way or another, we're concerned about its health. Something might be attacking it. Something's trying to disable McAfee. You get to define what your criteria is going to be, but I'll show you what I made my criteria. So there it is, under threat, very similar to what I did before. I'm going to go to automatic responses, and we are going to choose McShield stop attempt right there. So that's the criteria that I made mine. I'll show you what that looks like. Again, it's very similar. It's a threat event, and again, I defined it at my organization. So this applies to everyone. Now what's unique is we all know that in VirusScan there's something called access protection rules, and that's what protects McAfee services and processes from being altered by a piece of malware or an administrator who tries to disable our service. So in our case, the event, and you know, I had to look this up because it's certainly not the easiest thing to remember, But under event description, we have a couple of different ones here. So one is prevent termination from McAfee processes, prevent modification of files and settings. As you can see, there's a couple more, but I chose these two, this one and this one. And I said if either one of those events, either or, as you can see I did or, comes into EPO, well, that to me says something is trying to disable McAfee. Maybe an administrator, maybe a new piece of malware that we are not detecting. And if VirusScan does its job, it will prevent that disablement or stopping of the McAfee services. But let's hopefully, if it does do its job, we want to maybe take a closer look at that machine. And that's where getSUS comes into play. So I go ahead and hit next. And again, trigger it for every event. And then for the system command I want to run, under threat. That's the tag that I'm going to apply to any of these machines. I go ahead and hit save, and now I have an automatic response. But what do I actually have under the assigned client task? And here it is, deploy getSUS. It's nothing more than a deployment task that deploys this tool, which again you can get from that link that I had on the previous slide, or just do a simple Google search. This tool that I checked into EPO, I'm going to deploy it only to machines that have that tag. And how do I define that? I'm going to click Edit Assignment, and here it is right here. Send this task to only computers which have the following criteria under threat. Again, the big picture here is we're assigning a tag that says under threat. We deploy only to these machines which have some new piece of malware that McAfee is not catching. Maybe it will catch it shortly in the next several hours, but this helps us be proactive, upload any possible malicious files, and gives you a great inventory as well, because don't forget, you can view all your tags through a report or right through the system tree. Maybe while you're perusing through your system tree, here's mine. Under tags, I noticed that there is a tag called under threat that will immediately tip me off that a machine may be possibly getting attacked, or someone's trying to disable the service inappropriately, such as an administrator, and I could take action from there. Again, we're adding automation to improve your daily workflow and essentially remove that manual overhead you have on a regular basis. That's it. Thank you for joining us today. We hope you found this session valuable, and keep an eye out for further best practices series on EPO.